Myself, Ajneesh Kumar Gupta, going to teach you something about organic chemistry, that is, chemistry of carbon and its compound. What are the reasons for the formation of large number of organic compounds? The reason is atoms combine to form molecules to complete the octet and to attain lower energy state so as to become more stable. When we carefully analyze, the element on the left hand side of the carbon have more tendency to lose electrons, while the elements on the right hand side of the carbon have more tendency to gain electrons. As carbon is in the middle of the second period, so it has equal tendency to lose or gain 4 electrons. But generally, it is seen that carbon neither gain nor loses electrons, instead it shares electrons with other atoms like hydrogen, fluorine, chlorine, bromines, iodines, nitrogen, oxygen, sulfur or phosphorus, etc. and form covalent compounds. Due to sharing of electrons with other atoms, many different functional groups are formed, resulting in large number of organic compounds. Carbons not only share its electron with other atom, but it also share with other carbon atom, thereby forming large chain of carbon compounds having single, double or triple bond. This property is called as catenation. Hence, position of carbon in the periodic table. This is the reason. That is, position of carbon in the periodic table, which includes its size, electronegativity, electron affinity, property of catenation, etc., is the reason behind the formation of large number of organic compounds. If we carefully analyze the different functional groups with sigma bond only may be alkane, where only carbon single bond or carbon hydrogen single bond is present. Alkyl halide, in which tetrahedral carbon is attached with halogen. Alcohol, all the cases are the tetrahedral carbon. That is, if C is directly attached to OH, it is alcohol. COC, it is called as ethyl. CNS2, primary amine. CSH, thiol. CSC, that is thioethyl. All these are the cases of tetrahedral carbon. They may have some functional group which have pi bonds. So, allow carbon oxygen pi bond. Functional group may be aldehyde, CHO. Here C must be attached to H or C. Another COC, that is ketone. COX, it is acid halide. COOH, carboxylic acid. COOC, it is called as acetyl. COOCOC, it is called as acid anhydride, and CONS2, it is called as amide. Multiple bond may be of carbon nitrogen bond derived from aldehyde or ketones. Maybe carbon double bond nitrogen attached with H, it is called as imine. If nitrogen attached with OH, it is called as hydroxylamine. If same nitrogen is attached with NS2, it is called as hydrazine. And if attached with NHPH, it is called as phenylhydrazine derivative. Along carbon-carbon double bond, it is called as alkene. Maybe carbon-carbon triple bond alkyne. Maybe carbon-nitrogen triple bond, it is nitrile. Or maybe nitrogen triple bond carbon, it may be isonitrile. Reason for the chemical reaction in organic chemistry. By looking at different functional groups, we find that carbon is either bonded with less electronegative atom or more electronegative atom to complete its octet. Due to these electronegativity differences, some electronic displacement take place in the molecule. The effect which creates electronic displacement in organic molecules are called as the electronic effect. This is important. These effects may be permanent or temporary. They are of following type: inductive effect, resonance, which is also called as mesomeric effect, hyperconjugation, and electromagnetic effect. These are the 4 main important electronic factors. Something for chemical reactions. Reactivity of a position in a molecule is determined by the charge density at that position. That is, electron deficient species, that is electrophilic reagent, will attack preferentially at the site of highest electron density, and electron rich species, that is the nucleophilic reagent, will attack at the site of the lowest electron density. This charge distribution is ascertained by examination of the consequences of electronic factors such as resonance, hyperconjugation, and inductive effect. These are the electronic factors. Some reaction proceeds to have formation of intermediates such as carbocation, carbon and free radical, carbene, nitrene, benzene. These are the reaction intermediates of organic chemistry, while other do not form intermediate but proceeds through transition state. But one point is common in both. Reactivity of different positions in the molecule are determined only by their relative activation energy. Since activation energy depends on the structure of transition state, so generally more stable intermediate have lower energy of activation energy, and consequently lower is the activation energy leading to intermediate formation. Inductive effect. This is the basic electronic effect which occur nearly in all organic molecules, because organic molecules are attached with single bond. When sigma bond is formed between two atoms of different electronegativity, then sigma bond pair electron density is shifted towards more electronegative atom, and due to shifting of electron cloud, dipole is created between the two atoms. Due to this dipole in sigma bond, electron density in the chain is also shifted and progressively moves into the chain. This permanent effect of polarization in the chain is due to a dipole is called as the inductive effect. So definition of inductive effect is the permanent effect of polarization in the chain due to a dipole is called as the inductive effect. Inductive effect represented by I effect. I effect is a permanent effect. It will always be present when carbon is attached to more electronegative or less electronegative atom. This effect is distance dependent. This is important. Inductive effect is distance dependent, and its strength is generally negligible after 3 carbon atoms in a chain. Inductive effect is additive in nature. That is, when two groups of similar nature are present in a molecule, then their effects are added, and if two groups of dissimilar nature are present in a molecule, then their effects are subtracted. One point should always be kept in mind that inductive effect always operates along sigma bond. That is, always think for inductive effect along the sigma bond. Never think inductive effect in pi bond, because pi bond some other effects are operative. The carbon hydrogen sigma bond is taken as the reference for inductive effect. It is also important, carbon hydrogen sigma bond is taken as the reference for the inductive effect. Shifting of electron density or polarity in a carbon hydrogen sigma bond is considered to be negligible, and inductive effect of hydrogen is taken to be 0. Inductive effect is a weak effect. Inductive effect is a weak effect since the sigma bond electrons are strongly held. A crossed arrow is often used to indicate the direction of the movement of electron. By convention, the electrons are displaced in the direction of the arrow. The tail of the arrow, which looks like a plus sign, is the electron over, and the head of the arrow is the electron rich, which is represented by delta negative. It is also important to remember that inductive effect creates only polarity in the sigma bond and not the ionization in the bond. It is also important, that is, inductive effect only creates polarity in the sigma bond and not the ionization in the bond. Inductive effect is also called as the transmission effect. In case of organometallic compounds, for example, lithium alkyls, that is represented by RLi, and Grignard reagent RMgx, carbon is bonded to less electronegative atom such as metal. Due to this electronegativity difference between metal and carbon, metals are electron donating in nature, leading to creation of positive negative charge over the carbon. It is also permanent. It is also important to remember that inductive effect is the atom ability to polarize the bond. Inductive effect is the atom's ability to polarize the bond. That is, shifting of electron in a sigma bond is in response to the electronegativity of the nearby atom. Types of inductive effect: on the basis of direction of electron flow along the sigma bond, which either makes carbon electron deficient or electron rich in nature. So on the basis of it, inductive effect is of two types. First, minus I effect. The atomic group which withdraws electron density, they are also considered as EWZ, electron withdrawing group, from the carbon, making carbon electron deficient, are called as a minus I groups, and effect is called as minus effect. Minus I group creates partial positive charge over the carbon and partial negative charge over the more electronegative atom. The strength of minus I is also important. Various groups with decreasing order of minus I effect. Nr3 plus followed by Sr2 plus followed by NH3 plus, then NO2 plus SO3H, Cn, CHO, carboxylic acid, fluorine, chlorine, bromine, iodine, OR, OH, triple bond, alkyne, NH2, phenyl, C6H5, vinyl, CH double bond CH2, and reference value is the H. Next important part of the electronic effect is the resonance. There are so many organic molecules, maybe neutral molecules, ions, free radicals, where all the observed properties, that is physical and chemical properties, cannot be satisfactorily explained with the help of a single structural formula, that is lab structure or the valence bond structure. In order to satisfactorily explain all the properties of such molecules, we represent the molecules by 2 or more structure just by shifting of pi orbitals electron, just by shifting of pi orbital electrons or delocalization of electrons without changing the relative position. This is important. We only change the position of electrons while position of atoms remains same of the atomic nuclei. These structures are called as resonating structure, canonical structure, contributing structures, or the resonance unperturbed structure, and phenomena is called as resonance. The resonating structures are only the hypothetical structures. That is, resonating structures are only the hypothetical structures and the real structure lies in between them. The resonating structures contribute to the real structure, which is called as resonance hybrid. The resonance hybrid is more stable than any of the resonating structure. Compound showing resonance is not a mixture of some molecule. It is important. Compound showing resonance knot is a mixture of some molecule having the structure shown by one canonical form and some having structure shown by another. But the compound showing resonance have the same structure all the time. That is, if we consider for benzene, all the carbon-carbon bond is same in all the resonating structure of benzene, in the real structure of benzene. General case of resonance. There are many cases of resonance which are commonly A double bond B, C double bond D. A double bond B, C have either positive charge, negative charge, free radical, lone pair. C may be triple bonded D. That is, A double bond B, C triple bond D may also be present, or A triple bond B, C triple bond D, A triple bond B, C have positive charge, negative charge, free radical, or lone pair. If we carefully analyze all the 13 cases, we find that A double bond B is common, C have either positive charge, negative charge, free radical, lone pair, double bond, or triple bond, and A have either negative charge or lone pair, and B have positive charge. A triple bond B, C have either positive charge, negative charge, free radical, lone pair, or triple bond. These are the cases. Points to the resonating structure. Resonating structure differ only in the placement of the pi electrons or non-bonding electrons. That is, sigma electron skeleton remains same in all the resonating structure. The position of each atom in the resonating structure must be same. All the resonating structure must be proper lab structure. That is, elements of the second period, that is carbon, nitrogen, oxygen, fluorine, cannot be expand their octet in any of the resonating structure. All the resonating structure must have the same number of paired electrons. If they have pi bond, positive charge, negative charge, lone pair of electrons of the same number of the unpaired electron. If they are the free radical. In any conjugate position, if any conjugate position has more than one lone pair of electrons, then only one lone pair of electron will take part in the conjugation or resonance. Neutral molecules are generally more stable. If we carefully analyze the stability, how to check the stability of resonating structure, there are some key points on the basis of which we find the stability. First, neutral molecules are generally more stable than charged separated structures. Greater the number of pi bonds, this is important, greater the number of pi bonds in a resonating structure, more stable the molecule will be. Resonating structure with complete octet for each atom is more stable no matter if electronegative atom has positive charge or positive atom have the negative charge. Resonating structure with electronegative atom having negative charge and electropositive atom having positive charge are more stable than those in which electronegative atom having positive charge and electropositive atom having negative charge. When number of pi bonds are same, it is important when number of pi bonds are same, then only you should consider for this point. But if there is a difference in the number of pi bond greater the number of pi bond, greater will be the stability of the resonating structures. Resonating structures with similar charge on adjacent atoms are insignificant due to electronic repulsion and result into instability in molecules. Structures with two fully positive charge or partial positive charge on adjacent atom, two fully negative charge and partial negative charge on the adjacent atom, or negative charge and lone pair on adjacent atom are insignificant. Resonance stabilization is more when at least two equivalent structures are possible for a molecule. As conjugation increases in a molecule, stability increases. If conjugation is same in aliphatic and aromatic compound, then aromatic compound is more stable. Structure with linear conjugation is more stable than those in which cross conjugation. If two atoms are in conjugation with a particular group but not in conjugation with each other, then such system is called as the cross conjugation. Thus, similar chemical structure vary widely in the energy content. That is, those canonical structure having higher energy contribute less to the resonance hybrid, and canonical form having lower energy contribute more to the resonance hybrid, and equivalent resonating structure contributes equal to the resonance hybrid. Resonance is distance independent. This is the most important point. Resonance is distance independent, and delocalization of electron occur from one place to another till the conjugation is present. Resonance energy is the potential energy difference between the most stable resonating structure and real structure, that is resonance hybrid, is called as the resonance energy. It has a fixed value for a molecule, that is for benzene it is 36 kJ per mole. Resonance stabilizes the molecule, and that is it lowers the energy content, which can be revealed by low heat of combustion and lower heat of hydrogenation value. Mesomeric effect. It is simply the resonance occurring in a molecule when any atom or group of atom in a conjugation with organic molecule. In general, there is no difference between resonance and mesomeric effect. Heisenberg in 1926 called this resonance, and Ingold in 1933 called this mesomeric effect. There is only minute difference. A very minute difference is there between resonance and mesomeric effect. That is, when a molecule which do not have any polarity, such as 1,3-butadiene, is considered, then pi electron may move in either direction, that is from left to right or right to left. In such case, resonance is operating in this molecule. But when the same molecule is attached with CH group, that is CH2, CH, 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 CH2, an electron will always move from left to right. In such case, due to CH group, carbon acquires positive charge and oxygen acquires negative charge. Therefore, in such case, same resonance is called as the mesomeric effect. Type of mesomeric effect. Similar to inductive effect, mesomeric effect is also two types. They may be plus M effect or maybe minus M effect. Plus M. Those atom groups which donate electron density toward the conjugated system are called as plus M groups, and the effect is called as plus M effect. Plus M group in decreasing order power follows O negative, NS2, NHR, NR2, OH, OR, NSCUR, OCUR, pH, vinyl, fluoride, chloride, bromide. The basic behind the M is the atomic overlapping. That's why the power of NS2 is higher than NHR, followed by NR2. Minus M effect. Those atom groups which withdraws electron density from the conjugated system are called as the minus M group, and the effect is called as minus M effect. A minus M group in decreasing order power follows NO2, SO3H, CN, CHU, COR, COX, COO, COR, COOR, COOH, CONH2, CONHR, and CONR2. Capsule of Mesomeric effect. Atoms directly attached to the atom, we have to think for the atom directly attached to the conjugated system have at least one lone pair of electron or negative charge with complete octet are said to be plus m group, and the atom directly attached to the conjugated system have multiple bond, double or triple. The more electronegative atom without lone pair of electrons are said to be minus m group. Hyperconjugation. Inductive effect of alkyl group follows the order tertiary, secondary, primary, and followed by methyl when attached to saturated carbon. But once they are attached to unsaturated carbon, that is carbon-carbon double bond or aromatic ring, then order is reversed. This abnormal behavior of electron release can be explained by a new concept other than resonance and inductive effect, which is called as the hyperconjugation. So the concept of hyperconjugation arises by looking about the abnormal reaction of toluene and tertiary butyl benzene. Here, electron releasing effect can be explained by assuming that sigma orbital of alpha carbon hydrogen bond overlap with the adjacent pi orbital. This displacement of electron pair of alpha carbon hydrogen bond causes partial positive charge on hydrogen atom without the actual proton release. Ability of sigma bond dead electron of an alpha carbon hydrogen bond to undergo conjugation with the adjacent pi electron is said to be hyperconjugation. The concept of hyperconjugation is generally applied to carbocation, free radical, and carbon-carbon double bond, maybe of alkene or aromatic compounds. In case of carbocation and free radical, the carbon atom having positive charge or unpaired electron respectively is alpha carbon. Therefore, in that case, only the electron in the carbon hydrogen sigma bond that are the beta to the positively charged carbon or free radical shows hyperconjugation and can stabilize them. In case of alkene, the carbon adjacent to the double bond carbon is alpha. Here, the electron in the carbon hydrogen bond that are alpha to the double bonded carbon atom stabilizes in it by hyperconjugation. Hyperconjugation is also a permanent effect similar to resonance and inductive effect. It is also distance independent similar to resonance. Hyperconjugation also increases the stability of molecule. Greater is the number of hyperconjugation, greater is the stability, because it is also a stabilizing phenomena similar to resonance. So resonance and hyperconjugation may be considered as a wire, naked wire, where current is flowing, while inductive effect is considered as a fire. So naked wire can harm more as compared to fire. So the inductive effect is distance dependent, considered as a fire, while resonance hyperconjugation is distance independent, can be considered as a wire. Thanks for this lecture. Hopefully I think that you have enjoyed.